7.1, order of operations. So we're going to take everything we've learned, and where in the past, I mean, we mix things up, but just kind of one operation at a time. Now we're going to be looking at these multiple operations at a time. So you may see some addition and subtraction mixed in with some multiplication and division, but also some exponents and some parentheses as well. And parentheses take on a few different formats, which we will see. Now, before we get into the actual order of operations, we need to talk about the distributive property. Mostly because it's part of the assignment that you force distribution to happen. But do understand, though, that by the order of operations, at least the way that we're going to be using it today, we would not necessarily need the distributive property. So I'm going to show it because it's on the homework, but I'm not going to be using it in the problems, which you will see. Okay? And that's because, well, we're only dealing with numbers. The distributive property is really nice when you have variables inside parentheses or letters, right? And yes, I know those letters, but they're supposed to be numbers in here, okay? So where we're dealing, well, all the stuff we're dealing with today, I will not be using the distributive property except for on this one problem. Now, we have seen distributive property, and it is pretty much just multiplication, by the way. If you're ever wondering, well, what operation is distributive property, it is always multiplication. So that's why here it's just, hey, you took A times B, well, you can just write that as A times B. But if you're multiplying by a set of parentheses that have many values in it, whatever's on the outside has to be distributed inside that set of parentheses. And we usually show that with a nice rainbow here like this. And there's a double rainbow, which for those of you that remember, I mean, it's enough to make a full-grown adult human cry. These double rainbows. And it's all multiplication. So that's A times B there first, which we see here. That's what we got in red. And then the second rainbow shows A times C. You don't have to call them rainbows if you don't want to, but whatever. A times C second. So you can do that multiplication, and then whatever you get from those products, that's what you will then add. But right here, where we're doing addition, it also works for subtraction as well. So you say, well, A times B, that's what we get here. And then the second rainbow, A times C, and then it changes the operation. It doesn't matter if it's addition or subtraction, distribution still works. In fact, like we showed here at the top, where you can multiply by one value at a time, or in the second two here, you got two different multiplications. It is possible to distribute into three or more different values as well. But for today, we're just going to be focusing on these types, okay? So that's a nice quick introduction to distributive property. It's just really important that you remember that it's multiplication, because that's really all we're going to be doing with this stuff. So we got three different, boxes essentially to fill in on this. Okay, so it says right as the sum or difference of products, right? So let's go and split this up now so we can kind of keep track of what we're looking at here. So we're going to do 2 times 3 plus 4 along this line, and then negative 2 times 3 minus 4 along this one, okay? But it says, first, write as a sum or difference of products. And again, this would be a box that you would need to fill in. Let's go ahead and figure out what we're going to be doing with some distributive rainbows, if you want to call them that. So first off, we'd have 2 times 3. And again, the operation does not change. It's still going to be addition. And then I would do 2 times 4 next. 2 times 4. So this is the sum of products. Sum because it's addition. None of these are negative, so I don't have any parentheses yet from the multiplication. There's no need for the parentheses. But now I will actually find the product. So first in red, 2 times 3, I know is 6. And then in purple, 2 times 4 is 8. So I'm going to take those two values and add them, and that will be my final result. 6 plus 8, I know, is 14. I'll just reiterate this, though. All three of these would be boxes that we would need to fill in on this assignment. Okay, so this would be a box right here that you got to fill in. This would be a box here that you have to fill in, and then this would be a box that you fill in. Okay. Now I'm going over this again because it's on the assignment, but It wants it in a very specific way when we're dealing with negatives. So be careful on this one. First off would be distributing this -2 into the set of parentheses, right? So -2 times 3 first. So I would write this as -2 times 3 here like this. However, there's -2 times 3, but we are performing some subtraction. That -2, it should say this on the assignment, it wants all negatives in parentheses. So we need this -2 in parentheses like this. And in addition to that, notice that I've shown the multiplication here. That's going to be required on the assignment as well. So make sure you put the multiplication there. You cannot put just -2 in parentheses and then the 3. You have to show the multiplication. That's just the asterisk button on the computer, however you want to look at it. But then we're going to take that -2 and distribute it into the 4 as well. Keeping the operation subtraction means that would have the -2. Since it's negative, I still need to put it in parentheses, but we'll multiply it by 4. So that would be that box that we would need to fill in. Next up, we'll find the products of these. First, the red products, -2 times 3, which is -6. So I'm going to put that in parentheses because it's negative. And then in purple, we got -2 times 4, which is -8. That also goes in parentheses. We are looking at subtraction here. Now this is what I would put into that box. -6 in parentheses minus -8 in parentheses. But I'm going to show the rest of the work on this. I'm going to use that keep, change business. So that means I'm going to keep the -6, -6. But I'm going to change the operation from subtraction to addition. And I'm going to change the sign of -8 into +8. Keep the -6, change the operation, change the sign. Now it's -6 plus 8, and yeah, I can solve that. I know since we're dealing with addition, I want to find the sign of my answer first. And I see that the 8 is bigger than the 6. 8 is positive, so my answer should also be positive here. Then we just take the bigger of the two values, 8, and subtract the smaller of the two, 6. 8 minus 6 is 2. And so my final answer here, +2. I don't really need the positive sign though. And then we'll just box this in, because it will be a box that we need to fill in. So do keep in mind that you're going to see this more often when you go into your next class, this distribution stuff. I do not use it in this class because there's not really a need to use it, and that is because of the order of operations. What you'll see, and this is when it becomes really useful, is when you have letters in there. Instead of a 3, maybe an X right there. Okay, then you'd have an X right there, and that changes everything, by the way, but it's more useful in the next class, not this. So here is our order of operations. I don't think we're going to see any absolute values today, but that's what this is looking at. Regular parentheses are good, and this is the fraction line right here. So we treat the numerator and denominator as though they have parentheses. So we got to focus on these one at a time. You will also see square brackets that, I don't know, kind of look like this. Okay, so we're going to see those square brackets today, but not the absolute values, although they are treated as though they are parentheses. So it goes parentheses first. You got to look for any parentheses first. Then you would look for exponents. Then you would look for multiplication or division from left to right. And that's key word right there, or, because sometimes students think that you can only do multiplication first. You have to do multiplication first, but that's not true. Sometimes you need to do the division first, and it depends on which one occurs first from left to right. You're going to scan it, scan whatever expression we're looking at from left to right. After you finish multiplication or division from left to right, then we look for addition or subtraction from left to right. So, just like multiplication or division, sometimes students think that you have to do addition first before addition. That's before subtraction. That's not true always. Sometimes the subtraction will occur first from left to right, and so it just happens to be first on the list in the order of operations. some people remember the order of operations as PEMDAS. Be careful with that because students that memorize it like that tend to think that multiplication is automatically first, but it's not true. Sometimes addition is first. Sometimes division is first, and sometimes subtraction comes before addition. So it could be PEDMSA or PEDMAS, PEDMAS. There we go, something like that. Okay, but the order of operations is crucial because it allows us to take what will look like big problems and narrow these down into smaller, more manageable problems, part by part. So it really simplifies things for us, but not only is going to help us that way, but it's going to make things a little bit more organized for us as well. So the order of operations is about organization. And the organization, by the way, is what allows this to become kind of what they consider a universal language. So for example, you'll see some problems. I'll point out some mistakes on some of these problems that you'll see that are very common. We see these as teachers all the time. And I'm going to point these out so you hopefully will not make the mistake or not make it as often. But the common mistakes are because students tend to do things out of order. Usually it's a left to right thing, not necessarily an operations thing, okay? So, we still have to be careful on these, and it allows everyone to do the problems the same way instead of if you do them not the same way, then you end up with lots of different answers, and that creates problems not only for I guess scholastics, but also communication, right? Because if we're all of math is really just a form of communication, and so we need to be able to express things and know that it can be done the same way. The order of operations, by the way, is kind of how it has the same logic behind it as computer programming. So if you can get down the order of operations, I'm talking really about spreadsheets, right? You could write your own programs for any kind of spreadsheet, but this is the basis for a lot of that kind of stuff. So there's our order of operations. Again, we just need to remember that multiplication or division happens from left to right. So division may happen first, or addition or subtraction from left to right. So subtraction may happen first. Okay. So on this one, we're going to start with our parentheses first, and I see a set of parentheses right here. Now, when I look at these, like I said, it's supposed to organize these problems so that we're only looking at these one piece at a time, not multiple pieces at the same time. And for me, I'm just going to focus first on this 6 minus 2 inside the parentheses. Well, I know 6 minus 2 is 4. So that's evaluated that set of parentheses right there. That's good. That's what we want. That evaluates it because I've narrowed that set of parentheses down into one individual value. There's no other values or operations inside that set of parentheses right there. So at this point, I will apply all the values on the outside of the parentheses. That's 3 plus 4 here, and then it's the same 3 plus 4 there. Okay. Now you may be wondering what operation we do next, and that took care of the parentheses for us. I do not see any exponents. Now, you may not see it, but there is multiplication, okay? So, where's the multiplication? Remember, if you do not see the operation, it has to be multiplication. I'm looking between the two 4s there, the black 4 and the red 4 in parentheses. That is multiplication right there. I don't see any division, and so scanning this, just remember, we're scanning this 3 plus 4 multiplied. Boom. We got to do that multiplication next. 4 times 4 is 16. So that takes care of the multiplication, and then I'm left with 3 plus 16. And just at this point, remember that this problem originally started with 4 different numbers, 3, 4, 6, and 2. We've now narrowed that into 2 different values, but we're going to narrow it even further into one value because our next operation is addition. Once you get down to one operation left over, that's the only operation you need to do. It doesn't really matter which one it is, but I know that 3 plus 16 is 19, And that would be my final answer for this one. So on this one, I would start with parentheses. Now we notice something about this set of parentheses here, that there's many different values on the inside of it. That's okay. Whenever you see a parentheses, you go inside the parentheses, and you pretty much start the order of operations again, okay? So on inside this set of parentheses, I do not see another set of parentheses. I also do not see exponents, so that takes us directly to the multiplication of 2 times 4 right there. So 2 times 4 is 8, and that's all there was with multiplication and division. So I'm going to show the minus 3, and then inside that red set of parentheses, we would have 8 minus 3, which is 5. So that evaluates that red set of parentheses there. Of course, we still have the stuff on the outside, the 23 minus 3 here. So that's really 23 minus 3 times 5, right? And so there was no exponent. I don't see any exponents anyways. And, well, yep, we got the multiplication there between the 3 and 5. So let's go and do that. 3 times 5, I get 15. So then this becomes 23 minus 15. So we took what we started with, looks like 5 values, and we've narrowed it down into 2. The final operation here we see is subtraction, and that's our final step in the order of operations. So we'll just do 23 minus 15. You can stack it if you need to. I'm going to skip that step and just show that the answer is 8. Okay, so this one, I'm going to point out the mistake on this one, and it happens often with the previous 2 problems we just went over. So the mistake that we see often on the problem like this is to say, well, 12 minus 5 is 7, and then you do 3 minus 7, which is 4 right there, and then you got 7 times 4, you get 28. You're going to see that the answer is not 28, and that's because this was done out of order, right? The 3 minus 7, it's okay to do it second, but, well, no, it's not okay, but 12 minus 5 is definitely not, well, it is 7, it's definitely not in order. It's out of order. Okay, you'd have to do the multiplication between the 5 and the parentheses first. So remember, that's a common mistake enough that I've seen it even in teaching the 10-10 type classes. So be very careful with these. You need to remember this order of operations stuff. The order of operations is highly applicable in mathematics. Not so much in everyday life, but definitely in mathematics. So you're going to see this often and a lot, and in many different scenarios in all of your math classes from here on out, okay? So we'll start with parentheses, and we do have a set of parentheses right here with the 3 and the minus 7. So that's what we're going to do first. 3 minus 7, I know is, well, I should change that, shouldn't I? Because remember, we don't actually subtract these values. Here I'm taking away from 3 more than what we start with. So I'm going to use keep, change. That'd be 3, keep it, 3. Change the operation from subtraction to addition, and change that positive 7 into a negative 7. Well, why do we do that? That's because that's what we're used to doing with these values, is adding the different types of values, positives and negatives. So now I see that my 7 is bigger than the 3. It's negative, so I know my answer is negative. And we just take the 2 values, 7 and 3, and subtract them. Big minus small. 7 minus 3 is 4. So I get a negative 4 inside that set of parentheses. And that fully simplifies that set of parentheses right there. Now I look to the outside. Remember, we got the 12 minus 5. So it's still 12 minus 5 times that set of parentheses. And yes, I am showing the multiplication here because it wasn't shown before. But we need to see that because we just cleared the parentheses. Again, I do not see the exponents, but I do see multiplication, only multiplication, no division yet, between the 5 and the negative 4. So 5 times negative 4, that would give us negative 20, because there's only one negative, so the answer is negative right there. And so this then reduces into 12 minus that negative 20. I'll keep that in parentheses in case it helps. But once again, it's subtracting with a negative value, so I'm going to change this into an addition problem, which will keep, change. Keep the 12, 12. Change the operation from subtraction to addition, and change that negative 20 into a positive 20. That's just 12 plus 20. That should be easy enough for us either way. 12 plus 20, well, guess I ran out of room, but 12 plus 20 is 32. So that's positive right there, by the way. So the final answer here is positive 32. Usually when I do these problems, at least when I'm on my own here, is I usually just change this into a big plus sign. So if that helps you out more, then remember you can always do that with double negatives. Now I like this problem perhaps more than I should because it emphasizes that sometimes division happens before multiplication. If you go out of the order of operations, you would do 3 times 2 first because of, well, if you remember PEMDAS as though it were strictly PEMDAS and it couldn't be PEDMAS, then yeah, you end up with problems like this. But you cannot do 3 times 2 first. That's out of order. Just looking at the order, though, there is no parentheses. There is no exponent, so that brings us to multiplication or division from left to right. So I scan this problem starting with the 9 on the left and go to the right. And what's the first operation I see? It's division. That's okay that we see division first, but if I see it first in scanning, I need to do it first. 9 divided by 3 is 3. Then I would multiply that by 2. Well, 3 times 2 is 6. And, well, that takes care of all of our operations, which means that our final answer here is just 6. Right? We cleared multiplication. There was no addition or subtraction, so that's it. Now, if by chance you were using distribution on this one, you would have to be careful not to distribute the 4 first, which is why I'm not using distribution, by the way, just because of the order of operations. I mean, I do have this set of parentheses, and that's what we should start with, but sometimes when we see those set of parentheses, be careful on this later on because students do this, especially with the exponents. You cannot multiply that 4 on the left into that set of parentheses especially because of the exponent, okay? Even with distribution. But when we're dealing with just numbers like this, we should really just be looking to use the order of operations. So I would look inside the set of parentheses. I see 3 plus 4. I know that's 7. Then I apply everything on the outside of the set of parentheses. That's 4 times 7 to the power of 2. Now at this point we see a common error as well, where students would multiply 4 and 7 to get 28. That's not good because it's out of order. Remember that this multiplication has to come after the exponent 2. So that's our next step here is to perform the exponent of 2. That's 7 to the power of 2, which is 7 times 7. So again, I'm not writing the 4 out. I'm just focusing on the 7 times 7, which I know is 49. So that green 49 came from 7 to the power of 2. Now I will look to multiply by the 4. And whatever I get from this, because that's my final operation, that's going to be my final answer. Let's see, 4 times 49. Let's go and stack that over here on the right. Just multiply these. 9 times 4 is 36. Carry the 3. 4 times 4 is 16. But add the 3 makes that 19. So final product here is 196. And that will be our final answer. So this problem is kind of like the division and multiplication problem. This is just to show you that, yeah, sometimes you got to do the subtraction first. You have to do it first because we would scan this from left to right. Let's just go through our order of operations first. I do not see parentheses. I do not see exponents. In fact, I don't even see multiplication or division from left to right. So that brings us straight into addition or subtraction, but it has to happen from left to right. So you may have to perform the subtraction first, just like we see on this one, with the 33 minus the 14, which we see the subtraction there. It's first on the left, so yep, we got to do that first. Yeah, let's do this again. 33 minus 14, yeah, it's not 9, dang it, 19. Felt like something was off on that. So that, again, we did that first because of the subtraction, then we add the 74, and yes, this one is why I probably should have stacked it, but didn't, dang it. 19 plus 74 is 93. Yeah, I'd have to carry the... you know what? I'll show the work over here on the right. 74 plus 19. just because I'm feeling a little incompetent now. So 9 plus 4 is 13, carry the 1. 1 plus 7 is 8 plus the 1 is 9, 93 there. There we go. That's much better. Here's a problem that doesn't have parentheses. We're going to skip this one. In fact, I don't see exponents either, but it does have multiplication and division. Which one comes first, though, from left to right? That's the important question. So scanning this from left to right, boom, I see this division first. So that's what I would have to do first. Now, along those lines, that means we're just focusing on 12 divided by negative 6. Nothing else. Ignore the rest of the problem for now. We'll come back to it later. 12 divided by negative 6, that's 1 negative. 1 is odd, so I know the answer is negative. 12 divided by 6 is 2, so we get negative 2 out of that. I'll put it in parentheses. So that concludes the division portion of this. Let's look at the rest of the problem. That'd be 2 plus that purple negative 2. Then we would add the 5 and multiply that by 4. So I took everything on the right and added that to the problem there. But we're still on multiplication or division from left to right. And yes, we have this multiplication here. 5 times 4 is 20. So that's what we focused on right there. But applying everything else, that'd be 2 plus that negative 2 in purple. And then add the purple 20. So that concludes the multiplication or division from left to right. Now we're on the addition or subtraction. I don't see both, but I see one. Addition 2 times. And moving from left to right, which we should do, I would do positive 2 plus negative 2. They're just opposites of each other. Remember, when you add opposites to each other, you end up with 0. That ends up being 0 plus 20. You could just make that a phantom 0 right here. So that would just leave you with, well, positive 20.